What's up, guys? Welcome back to another video from Math Tutorials. Today we have more AP Calculus BC practice. Even though I already took the test, my teacher's still giving us practice because we're still going to have tests in class. Anyways, I think there's some people that take it in a couple weeks still, so maybe this will be useful for somebody. So this is a no calculator question. Looks like we have a slope field, but let's read the problem here. Consider the logistic differential equation dy dt equals y over 8, 6 minus y. Let y equals ft be the particular solution to the differential equation with f0 equals 8. Okay, a slope field for the differential equation is given below. Sketch possible solution curves through the points 3, 2, and 0. Okay, so this is pretty easy. So we're given the points. They're kind of hard to see, but there's that one there, and then I think this one there. It's pretty low res. But for a slope field, they already give us the slope field, so we just have to draw some lines that look like they could reasonably go through these points. So if you start there, it looks like it would go about there, and then like that, kind of. And then if you start here, it looks like it would kind of go like that, and then like that. And I think that will be good enough for part A. So using Euler's method, starting at t equals 0 with two steps of equal size. Oh, use Euler's method, starting at t equals 0 with two steps of equal size to approximate f1. Okay, so for Euler's method, what we need is the coordinate. We need delta t, we need dy dt, we need delta t times dy dt, and we need our new coordinate. So these are the kind of 5 columns that I like to set up. This is the method I was pretty much taught in class. So the coordinate, our first coordinate, we're given f0 is 8, 0, 8. Now changing t, it says 2 steps of equal size to go from 0 to 1. So clearly if we go 2 steps of 0.5, we'll get there. So this is 0.5, now dy dt. We're going to plug our coordinate into this equation, which coincidentally only uses the y. So we're just going to plug in 8. So that'd be 8 over 8 is 1. 6 minus y is negative 2. Negative 2 times 1, of course, is negative 2. Now this means we multiply these two columns. So that'll be 0.5 times negative 2. Of course, that's negative 1. And our new coordinate is basically this plus this, and this plus this. So our x is changing by 0.5, so it's going to go up to 0.5. And then our y is changing by negative 1, so from 8 to 7. And then we take this coordinate and we move it to over here. So we have 0.5, comma 7, and then we do the same process. This is still going to be 0.5. This will change, so we're going to plug 7 in now. So it'll be 7 over 8 times 6 minus 7. 6 minus 7, of course, is negative 1, so this is just going to be negative 7 over 8. And then these two multiplied, of course, the negative 7 over 16. And then this is going to be 1, of course. And then 7 minus 7 over 16 will be 6, and 9 over 16. I don't know how they feel about, mixed fractions, but I feel like it's easier for this problem. So this is our approximation. That's part B. Write the second degree Taylor polynomial for f about t equals 0 and use it to approximate f1. All right, so the formula for a Taylor polynomial about f0 is f0 plus the derivative of f at 0 times x minus 0 to the 1 over 1 factorial. This could be, I guess, if you could think about this as x minus 0 to the 0 divided by 0 factorial, I guess. But I don't feel like writing the x minus 0 to the 0 part. And then, of course, to continue the pattern, second derivative of f at 0, x minus 0, x minus 0. There's the square. And then divided by 2 factorial. So we need 3 values. We need this value, we need this value, we need this value. Now this first one we're given, we're told f0 is 8, so easy. We're 33% done. F prime of 0, we already found when we did this. We know it's negative 2. And if you want to just be sure, remember, plug 8 into there, 1 times negative 2. So that will be negative 2x. Of course, x minus 0 is just x. And now this one we have to find. We're not given the second derivative of f anywhere, but we can just take this derivative and find the derivative of it. Hence, the second derivative. So I'm going to unfactor it because I feel like that'll be easier. So 3/4 y minus y squared over 8. Now we find the derivative of this, and remember this variable is not the variable of differentiation. So the derivative of 3/4 y is not 3/4, it's 3/4 times dy dt. And a similar kind of idea with the other term, it's chain rule, so that'd be 2y over 8 times dy dt. And of course, this simplifies to 3/4 dy dt minus y over 4 dy dt. So I'm going to factor out the dy dt now, just kind of make it look nicer. And then 3/4 minus y over 4. So we already know, and then we're going to plug in our y. So we know our y is 8. So we already know that if we plug in 8 into this equation, we could substitute this equation with, the actual thing right here. This part, we could do a direct substitution and then plug in 8, but we already know it's going to be -2 from our earlier problem. So I'm just going to do this, -2, 3/4 minus 8 over 4. So that would be -2 times, what, -5 over 4. The negatives are going to cancel out. And then the 2 and the 4, we're just going to make 5 over 2. So this f double prime 0 is 5 over 2. And then we're going to divide that by 2. So this whole coefficient will be 5 over 4 x squared. And now we want to plug in 1 to find the approximation of 1. So of course 8, -2 times 1, minus 2, plus 1 squared is 1, 1 times 5 over 4, 5 over 4. So that's going to be 6, and 5 over 4, or 7 and 1/4, 7 1/4, or what, 29 over 4, whatever they want. I don't actually think it matters, but we're just going to say that. So that's our answer for this. Now, what is the range of f for t is greater than 0? So we know f starts at 0, 8. So we're talking about just this positive part, right? Just this part to the right. So it seems like it's kind of just going to go start here and just go down. And it looks like it's going to approach, looks like 6 maybe. And that kind of makes sense. If you look at the derivative, anything less than 6 would be positive. So it would increase. And then once it gets past 6, it'd be negative. So it's going to go back down. So it seems like 6 is going to be kind of where it stays. But for this, since we're starting above 6, we're going to start going down. And then we're never going to quite reach 6. But we're just, oh, wow. We're just going to keep kind of approaching it forever. So it seems like our range, so the range would be y, I guess. So it looks like it's always going to be less than 8, right? Because it's going to start going down. It's never going to go up. But it also includes 8 because we're saying greater than or equal to 0. And at 0, it is exactly 8. And it looks like it's never going to reach 6. It's always going to be a little bit bigger than 6. So this would be our range. All right, hopefully this one wasn't too bad for you guys. And if it was really bad for you guys, hopefully you still have time to study before the AP test, or maybe you're just not taking the AP test and you're watching this video for whoever, who knows what reason. But yeah, if you already took it, hope you did well. If you're still going to take it in a couple weeks, good luck. And I'll see you next weekend. Goodbye.